All right, so now that we've seen what some of the vulnerabilities might be for hashed passwords, it's time to level up and learn about a way that we can prevent these types of dictionary attacks or hash table cracks. And in order to do that, we have to learn about salting. Now, what exactly is salting? Well, we already know what hashing is. It's when we take a password, we run it through a hash function, and we end up with a hash that we store on our database. And as we saw in the last lesson, passwords that are generated by humans are extremely insecure. They tend to be very short and they tend to be dictionary words that are extremely easy to look up and create a hash table for. Now, salting takes the hashing a little bit further. In addition to the password, we also generate a random set of characters. And those characters, along with the user's password, gets combined and then put through the hash function. So the resulting hash is created from both the password as well as that random unique salt. So that means no matter how simple the password of the user is, adding that salt increases its complexity, increases the number of characters, and we make our user database a lot more secure. So consider the previous problem that we saw in the last lesson, where we covered Hacking 101. Now we know that 3 of our users have the same password, and we figured that out because they all had the same hash. Now, on the other hand, if we had generated a random set of characters, which is the salt, and combined the password with the salt in order to generate the hash, then they won't have the same hash in our user database. So let's try and generate Emily's hash from her password. So we know that her password is QWERTY, and we generate a random salt. So then let's go ahead and put in her password, QWERTY, and then we append at the end that random salt that we generated, and we end up with a hash. Now, this hash, however, is not the same as Tony's hash or Angela's hash because the salt is different each time. Now, the salt is something that the user doesn't have to remember, and instead it's stored in the database along with the hash. So that means when the user types in their password when they try to log in, you combine their password with the salt, and if you generate the same hash, then they must have had the same password. It's kind of clever, isn't it? And on our database, of course, we wouldn't be storing their passwords, but only the salt and the hash. Now consider our previous statistics. You can generate about 20 billion MD5 hashes per second. So even if we added a salt and we made it harder to generate a hash table, with some of the latest GPUs, you can still probably generate a hash table with all salt combinations relatively quickly. So what else can we do to increase the security? Well, we can use something other than MD5, right? Another hashing algorithm that's valued because it's incredibly slow. And this is where bcrypt comes in. This is one of the industry standard hashing algorithms that developers use to keep their users' passwords safe. Because while you can calculate 20 billion MD5 hashes per second, even the latest and the greatest GPUs in 2019 can still calculate only about 17,000 bcrypt hashes per second, which makes it dramatically harder for a hacker to generate those pre-compiled hash tables. And a salted hash table, instead of taking something like 3 seconds if it was hashed with MD5, if it was hashed using bcrypt, it would take you something like 8 months, which is not really worth a hacker's while. They'll probably go and search out a company that has less security enabled. And to make our passwords even more secure when we're using bcrypt, it has a concept of what's called salt rounds. How many rounds you're going to salt your password with. And obviously, the more rounds you do, the saltier your password. And also, the more secure it is from hackers. So what exactly are salt rounds? Well, let's say that our original user password was QWERTY, and we generate a random set of characters as the salt. So now we have QWERTY and a random set of salt. We pass it through our hash function, bcrypt, and we end up with a hash. Now, that's one round of salting. If we wanted to have 2 rounds of salting, then we take the hash that was generated in round 1 and we add the same salt from before. And now we run it through bcrypt, the hash function, again, and we end up with a different hash. And the number of times you do this is the number of salt rounds. Now, the reason why this is genius is because as computers get faster, remember that Moore's law says that every year the number of transistors in a computer chip almost doubles and the cost of that faster computer halves. So every year you can get more computing power for less money. And this is where salt rounds comes in. When you're hashing your passwords using bcrypt, you can set the number of rounds you want to salt your password. So that means maybe this year in 2019, you salt it 10 rounds, but maybe next year you can increase that number to 12. And for every increase in that number, the amount of time that it takes to hash your password doubles. And so that means you don't have to change your hashing algorithm or update your code other than simply changing one number to keep up with the times. So just to review, coming back to that user database, we'll have each user's username stored, we'll have their randomly generated salt stored, and then we'll store their hash after a set number of salting rounds. And when it comes to checking their password when they log in, we'll take the password that they put in, combine it with the salt that's stored in the database, and run it through the same number of salting rounds until we end up with the final hash. And we compare the hash against the one that's stored in the database to see if they've entered the correct password. So let's give that a go in real life and implement bcrypt and salting rounds into our website's authentication. Now, the package that we're going to be using to hash our passwords using bcrypt is also called bcrypt, and you can find the documentation for it, as always, on npm. Now, bcrypt is a little bit peculiar about the version compatibility with Node. So if you're at all in doubt, be sure to first check your Node version by typing node-version or node-v. And you can see that currently I'm running the latest stable release of Node, which is 10.15.0 at this current point in time. Now, if you ever want to know what the current stable version is for when you are looking at this video, so this will update weekly or monthly. So by the time you're watching this video, this number might already be higher. So when you check out the Node versions, you can see that depending on your Node version, they also have a bcrypt version that is compatible with that version of Node. And they're very specific about not supporting the unstable versions of Node. So anything that is an odd number, bcrypt is not keen to support because it's less stable, there's more chances of bugs, and they always recommend you to use the latest stable version. So if you have an older version of Node, or if you have even a too new version of Node, how can you go back to this version that's on the left-hand side here on the Node.js website? Well, you could use something called NVM. And you can install NVM by going to its GitHub repository and simply copying this line of code and pasting it into your terminal. And once you've got it installed, restart your terminal, so close it down and open it again, and you should be able to check your version by writing nvm-version. And if you get a version back, then that means it's definitely installed and you can use it to update or downgrade your Node version. So we're going to aim for 10.15.0 or whatever it is that you see when you go on to nodejs.org, the long-term support version. And we're going to use NVM to install Node on that version by simply writing nvm install 10.15.0 and hit enter. And it will download and install that latest stable version of Node for you. Now, once you've got the latest stable version downloaded and installed, you can go ahead and look for the compatible version of bcrypt. So at the moment, we're on version 10 and bcrypt should be 3 or above. Now, at this current point in time, if I simply try and cd over to my secrets project and run npm install bcrypt, then you can see I get some warnings. And I suspect this is probably only going to happen for these few days while the bcrypt team scrambles to try and update their code. But if you get something similar like I do, how would you investigate to see how to fix this, or whether if you even need to fix it? With every npm package, there's always a link to the repository where the code is hosted on GitHub. And on GitHub, you can always explore the issues that people are having while they're trying to use this repository. And you can see that recently, 3 days ago, 5 days ago, everybody seems to be having issues with installing bcrypt. And if you click on it, you'll see a discourse or a chat or messages between the creator of the repository and people who are experiencing problems. And you can see whether if you're getting similar problems. Now, we don't have as bad as an issue as this guy, because they're actually getting errors and they're not actually getting it installed. And if you read through this, you can see what the solutions are that people are recommending. And at the point in time where I'm running it, the easiest way is to simply install a slightly older version of bcrypt, 3.0.2, whereas the most current version is 3.0.3. So in order to install a slightly older version, using npm, you still write npm I for install, and then you add in the name of the package, and then you have an @ sign. And after the @ sign comes the version that you want. So I want 3.0.2. So that is the version that npm is going to install for me. And you can see that when I change my installation command, I no longer get all of these problems, and I have my package successfully installed. So you might not experience this at all. You might not get any problems at all, other than maybe our 2 npm warnings because we don't have a description or a repository for our packages over here. But other than that, you might actually have no problems. But if you do experience an issue with bcrypt or any other package in the future, you'll know how to investigate the issue and see if there are some solutions being offered for that particular issue. All right, so now that we have bcrypt successfully installed in our project, the next step is to actually use it. So we're going to go ahead and swap out MD5, and instead we're going to be using bcrypt. So bcrypt equals require bcrypt. Then we define the number of salt rounds. So at the moment, 10 should be more than sufficient. And if you remember that the more that you increase this number, the harder your computer will also have to work to generate those hashes. And if you scroll down, it actually shows you how long it will take to generate your hashes, or how many hashes are created depending on how you change this number. So if you set that salt round number to 31, then on a 2 gigahertz core, you can expect to take 2 days or 3 days to generate a hash, which might look like your app is crashing, but it's actually just hashing away. So at least for 2019 and 2020, I would recommend keeping the salt round at 10. And to actually use bcrypt, we're going to use the hash function, passing in the password that the user has typed in when they registered, and also the number of rounds of salting we want to do, and bcrypt will automatically generate the random salt and also hash our password with the number of salt rounds that we desired. So let's go ahead and implement that inside our register post route. So inside our app.post for register, I'm going to paste those 2 lines of code that I've copied over from the documentation. And inside this callback function is when we would have generated the final hash after 10 rounds of salting, and also passing in a password. Now the password that we should pass in here is of course the request.body.password, which is what the user typed in to the password field when they tried to register. And inside this callback function, we'll have access to this hash that we can store into our database. So I'm going to select the rest of this code and simply paste it in here for it to run and create our user only once we've generated our hash. And I'm going to substitute the password field here for the hash that we generate. And then we're going to do exactly the same as before. We're going to save our new user along with their email and the hashed password into our database. So let's go ahead and run this and see if it works. So be sure to remove all the mentions of MD5 if you're going to remove that package from your project. You can see here I'm getting a warning. In my app.js on line 12, I've got a console log that uses my MD5 package, which is now, of course, removed. So let's go ahead and fix that. So on line number 12, I've got my console logs. So I'm simply going to remove these two lines. So let's go ahead and hit save, and NodeMon should restart, and you can see now our server has started without any problems. So whenever you're removing packages, be careful that you're not still using it somewhere inside your code. And let's head over to localhost 3000. Let's register a brand new user. And this user is going to be user at bcrypthash.com. And I'm completely making up these emails, but it just means that when we look at it in our database, it'll be easier to see which user was hashed with which hash function. So this user is a bad user because they're going to use a really simple password, 123456, and we're going to register. So we've successfully gone over to discover the secret page, which means that our user should have been successfully saved into our database. So let's go ahead and check it out. You can see that our last user, the one that we registered just now, has that email, user at bcrypthash.com, and their password is quite long, and it is a hash generated using bcrypt as well as 10 rounds of salting. So if you decide to try and search for this on Google or wherever it may be, or any sort of hash table, rainbow table, whatever it may be, you should not be able to discern the user's original password, which is key. Now, what about when the user tries to log in? So in our login route, instead of using MD5 to rehash the password that they've put in, we're going to be using bcrypt. And the way that they tell us to check our password is to use bcrypt.compare and generate a hash using this line of code. So let's go ahead and delete this MD5 part because we're no longer using it. And instead, we're just pulling in the username and the password that the user typed in on the login page. And then we're going to look through our database of users and find one where their email matches the username of the one that's currently trying to log in. And once we've found that person, then we have to check to see if the password that's stored is equal to the password that's currently being entered on the login page. And this is the part where we're going to substitute with the bcrypt compare method that we just copied over. So let's go ahead and paste that into here. And we're running this compare method, and we're comparing the plain text password, which is the one that the user's currently entered in. So we'll substitute that with password against the hash that we've got stored in our database, which is stored inside the founduser.password field, which is basically this over here. And then we get to check to see if the result is actually true. Now, at this point, some of you might have realized that there's a bit of a problem here, right? Because in this bcrypt compare method, the callback that they've defined uses an error and a res. Now, where else have we defined a res? Up here, of course. So in our callback, if we want to do res.render inside this bcrypt method, then we have to rename this something else just so that our code doesn't get confused which res we're trying to use. So let's go ahead and rename this to result, which makes it different from this one, which means that inside here we can check to see if the result of this comparison is equal to true, which means that the password after hashing with the salt is equal to the hash that we've got stored in our database, then that means that the user's got the correct login password, and we should res.render our secrets page. So let's go ahead and save our code and check that our server is still running without any errors. And let's go back to our home page and try to log in that user. So we've got our user at bcrypthash.com and their password was 123456. Hit login and we get taken to the secret page, which means that that comparison was successful. So that's it. We've managed to implement bcrypt along with salting, and 10 rounds of salting at that, to massively secure our user database and make it pretty much impossible to hack using something like a hash table or a dictionary attack. But we can still level up more, and we're going to discover that in the next lesson.